See, I'm going to tell him you guys don't care about him. All right, we're recording. Donovan, just
He's
so you
on
know.
the call.
I'm here now. Don't you know
Oh,
that?
you're here now. All right, fine. I'll
Yeah.
record it anyway.
Just in time.
Just in time. We're going to say things about you. All right.
Couldn't blame
So
you.
just so you know, not only will I post the stuff I've written down here, you know, and you're welcome to write it down, but I'll post that, but also the video if you want to go back and look. All right, couple refreshers. So I'm sorry if this insults your intelligence. First of all, natural log of 1 equals
0.
0. And you might be saying, how in the world is that chapter 1? Well, because when we're doing limits, they're going to overlap with a lot of the other stuff that we've done. And this is one thing that comes up quite a bit. The other thing that comes up quite a bit when we're doing L'Hopital, and we're going to include L'Hopital in limits, chapter 1 limits, is the natural log of infinity, remember, is infinity. And the one that has come up a lot for us, and I know you know this, is the 1 over infinity equals 0. So all of those little basics you got to keep in the back of your mind. Now here's one that goes way, way back. Does this notation look familiar at all to you? Oh, I'm going to imagine you're all saying, yes, it does. It looks very familiar. I don't remember exactly what it was, but it looks very familiar. Well, it was a graph of 2 horizontal lines. There was a horizontal line up here at +1 going this way. There was a horizontal line down here at -1 going this way. And the crossover point was right here at 1. So whatever this number is the crossover point. If this is x minus 3, it would cross over at 3. And the reason I mention that is because that comes up a lot of times on one-sided limits. You know, like on this graph, the limit as you approach from the left would be what, you guys? As you come in from the left, what's the limit?
-1.
-1.
But as you come in from the right, the limit is
1.
+1. What if I just said, what's the limit as x approaches 1? You would have to say,
Doesn't exist.
Doesn't exist. Okay, so there's a quick refresher there. L'Hopital, because of the format of this new test, I think they're going to be a little more lenient on the way you respond. But here's what I think. I think if they boil it down to 3 things, this is what they're looking for L'Hopital. I think you are definitely going to have to show that it's indeterminate form. Indeterminate. Oh my goodness, that was bad. Indeterminate. There we go. Form. I think you have to show that it's indeterminate form. And in a minute, I'll show you the minimum required. You know, we'll do an example. I think you're going to have to actually state that you're using L'Hopital, not in a sentence. I mean, just that. If you write LHOP, they're like, oh, look, this person knows they're using L'Hopital's rule. And then you'll actually have to show that you're taking the limit as x approaches, I'm going to say a, because it just depends on what the original was, of the derivative of the top over the derivative of the bottom. And here's where I think people are going to lose it. I think they're going to write this part, but forget that you have to show it's a limit. And I know they will be picky. If you don't show that you're doing the limit, you're not going to be able to get credit for this. Okay, so let me show you those 3 things. I'm going to go to example 25 on the chapter 1 worksheet, and it doesn't matter if you've printed it out or not. I'll show you what I'm talking about here. So if I'm doing number 25, when I first look at this, so I'm taking the AP exam and they don't say, oh, here's a whole bunch of L'Hopital for you to do. I have no idea what it is. I look at it and I say, well, the first thing I always try on any limit is substitution. And so if I substitute in a 0, on the top, sine of 0 is 0. And on the bottom, if I substitute in 0 to the natural log of this, I'm going to have natural log of 1, which is 0. So right there, because it is 0 over 0, I know it's indeterminate form. And I think you have to actually write what we have. Do not write 0 over 0. Because they don't want to think that you know that it equals that. They want to think you did the limit of the top separate from the limit of the bottom. And so then you're going to say, oh, I'm using L'Hopital's rule. And so all you have to do is write that. And then I think you have to actually say, now I'm going to do the limit as, in this case, t approaches 0. As t approaches 0. And then the derivative of the top is cosine. The derivative of the bottom is a natural log, so I'm going to do u prime over u. So u prime would be 2e to the t over u would be 2e to the t minus 1. Now, I'm not done, but here's where I showed L'Hopital rule. I'm sorry, here's where I showed it was indeterminate form. Here's where I showed I'm using L'Hopital. And then here's where I'm showing I'm doing the limit. I think they're going to look for that as a minimum. And then now I just have to finish it. If you want to clean it up, you can. I would just substitute. If I substitute 0 into the top, cosine of 0 is 1. And if I substitute into the 2e to the t, that's just going to be 2. And then 2 minus 1 is 1. And so that whole thing just equals 1/2. I think that's how much you would have to show to get full credit for this. Good there? We are, Miss Napier. I'm so glad to be doing L'Hopital again. It's like an old friend. Okay. Graphic representation of limits. Again, this might be an insult to your intelligence. That's okay. So if I have some graph, I don't know, let's say I come in from this direction to there, and then, on out, and we'll call this A. So the question, the limit as x approaches A of this function, does it exist or not? In other words, if there's a hole, can you still have a limit? Because a lot of times,
No.
once it's been a long time past, everybody's like, ooh, hole, that's a bad thing. No, it doesn't exist. That's not true, because remember, a limit just means when you come in from one side, does it go towards the same value as if you come in from the other side? And if it does, the answer is whatever your predicted y value is. So I'll make up a number. Let's pretend like we think that's 2. So that means the limit equals 2. So the limit does exist, right? But if instead of this piece over here, if it had been, up here somewhere, then we would say that that limit does not exist, right? Because they don't come together. I'm going to go back and put it the way it was, because I don't want you to look at it later and say, what? She said that in that. Okay, so all good there? It is, Miss Napier. Just keep going. Just keep powering through. All right, so graphic representation of a limit. Now let's talk about continuity. Look at just kind of the 3 different examples I have up here at the top, the 3 different graphs. Forget the pink, just look at the blue. If you're just looking at the blue graph, I think you guys would say, definitely the first one is not continuous, right? Because there's a hole. Second one, you'd say, oh, no, it's not continuous because the 2 pieces don't come together. There's a break in the graph. And then on the third one, there's a hole. Even though there's a point dropped out, it's still a hole, right? So if you knew nothing about calculus, you'd say none of those are continuous. Look at that, you guys. This is how you know that you're valuable to me, because I snubbed a call from my son just to talk to you all. I just,
I feel very appreciated. Thank you.
You know what? Just all about you. Okay, sorry about that. But now look at the pink part. If on the first one, when I look at it up here at the top, the fact that the 2 pieces come together means the limit exists, right? But it's because there's no point that's what makes it not be continuous. And another way of saying no point is to say that f of c does not exist, right? Just think in notation. On the second one, the limit doesn't exist, but the point does exist. Would you agree? Because there's an actual point right there. Okay. And then on the last one, the limit exists and the point exists, but it's still not continuous. So I had several different options. One time there was no limit, but there was a point. One time there was no point, but there was a limit. And one time there was both, but still not continuous. So I show you that because here are the 3 conditions for the definition. First of all, we have to know that f of c exists, which means that the point exists. Okay? The second thing is that you have to show that the limit exists. So when we say the limit exists, that means we're saying the limit coming from the left equals the limit coming from the right. Okay. And then finally, number 3, the limit has to equal the point. So here's kind of the idea that I think is kind of interesting to picture up here on this third graph. If that point had been moved up to fill in the hole, it would be continuous, right? Mm-hmm. But the fact that that point was not filling in the hole, I could erase it so that it's not filling in. The fact that that point was not filling in the hole is what made it be not continuous. Okay. Another thing that comes up is continuity and the idea of piecewise. So if I gave you this piecewise function and I said something like, hey, find the value of A that makes this be continuous. Do you remember doing these back in the day, which would have been like, the first week of school? So think back to August, just before Labor Day. If I said, what's going to make this be continuous? What we did was we said, well, hey, if I put in a 1, if I put in whatever that number is to the top piece, and I put in whatever that number is to the bottom piece, irregardless of if it said equal to or not, if I put those in, then I can set them equal to each other. That's what continuous means. Mm-hmm. So in other words, on the top, if I plug it in, I'm going to get 2. On the bottom, if I plug in 1 for x, I'm going to get a minus 1. Continuous means a minus 1 has to equal 2. Do you kind of now remember that we did that?
A little bit.
A little bit. I guess that's better than no bit.
Yes, now.
Wow. Okay. So I'm just going to keep it to that because I want to keep this kind of a short and sweet, jump start for you. When you get into it, you'll see a little bit more with asymptotes and limits. And I'll let you, kind of ask me if you need that. So I just wanted to kind of give you this jump start as you start in on that chapter 1 review stuff. Again, if you want to save up questions because you have several to ask me, you can do that. If you want to, just ask me as they come up and jump on, for a couple minutes here and there, I'm happy to do that. So homework for next time is whatever you can get done of chapter 1. Whatever it is, you submit it, but it's not actually completely due until the following class on Wednesday. And then any new stuff going forward, I'll try and keep all of that contained in a short video that we will completely do together. You have a little bit of an idea of where we're headed here?
Yes.
And I'll, it's like I said, as soon as I know more specifics on AP exam kind of stuff, I'll pass that along, and hopefully we'll have a little bit more of a permanent plan going forward. Okay?
Okay.
I have one last little bit of news, and I just need you to tell me if it's good news or bad news. I was thinking going forward, we really don't need online quizzes anymore.
Good.
Is that good news or bad news?
Yeah, it's good.
That's good.
And kind of both. It did help my grade a lot, but they were not fun to do because it required work. We try to do as little work as possible here.
Here's my thing. I think that because we're doing all of this review, and it just needs to kind of be a fluid thing where it's constantly you moving forward in review and constantly you kind of having a chance to ask me questions. I think we can have that all happen in real time, and I don't want to pile on extra things. I mean, what we need to do is review, period. And so there's no need for it to have to be like all over the place where you're trying to complete a bunch of different little tasks. Our goal right now, moving forward, is just constant review and you doing what you can in the time you have and juggling it with the other things that you have due. Okay? You guys, as far as, like Matthew, you said, help my grade a lot. You guys, you just have to trust me. From here going forward, if you just keep working with me, your grade is not going to go down. I'm telling you, it's not going to go down. It's going to do nothing but go up. Okay? And I know you care about your grade, and so therefore I do. But what I care about more is I know that we can get all of you guys to get full credit for this AP exam. And I just think it's going to be so valuable even more so now than it would have been before. Okay?
Mhm.
Trust me. I got
Okay.
you.
So we still have to take the exam?
The AP exam?
Yeah.
Of course you are.
Isn't there like an investigative task in it or something?
A what?
The,
I'd really
the
rather not.
question 6, it's like the really big free response question. Isn't that like half the AP exam now?
No. Nothing has been released about that yet.
Oh, okay. So that's all speculation.
It's all speculation. Like I was saying, I don't know if you're here yet or not, but I'm going to be going to a College Board forum for AP teachers tonight, virtually. And then tomorrow, they're supposed to have all the specifics posted.
Okay.
Yeah,
Is it like
nothing has been
confirmed
put
yet
out.
that, so it's not confirmed that there's no multiple choice or anything?
Well, it is confirmed that there's no multiple choice.
Oh, okay.
It is all free response, but that's what I'm telling you is I don't know that it's the old days kind of free response, or if it's going to be, like how you used to always take regular old math tests where they just give you, 20 problems that you work out. I don't know what they mean specifically yet. Nobody knows by free response. So anything that's out there beyond that is speculation, at least for calculus, because I haven't paid attention to what's been put out there on the other classes. I don't care about the other ones. Okay?
Okay.
There's every reason for you to take it. You gotta trust me. Okay? We're not quitting now. We haven't done a year of work for nothing.
Let's do it. I'm ready. Bring it on.
Atta boy, that's what I like to see. All right. It's gonna be fine. Annie, trust me, it's gonna be fine. Okay?
No.
Okay, we'll talk. All right, you guys. I'll get this posted for you, and then you're welcome to just let me know what you need. Okay?
Okay,
All right. Good
thank
luck to
you.
guys.
Okay. Thank you.
See ya.
Bye.
Bye bye.